物质中的 science. No. Hi everyone, this is Chichen and Nemo, and today we are going to discuss the first derivative test. Introduction. In order to determine which interval on a function is increasing and decreasing, we can apply the first derivative test to find relative extrema on a function. Increasing and decreasing function. In function f is continuous on the closed interval a to b and differentiable on the open interval a to b. If f prime x is bigger than 0 for all x in interval a to b, then f is increasing on a to b. If f prime x smaller than 0 for all of the x in closed interval a to b, then f is decreasing on open interval a to b. If f prime x is equal to 0 in all of x in closed interval a to b, then f is constant on open interval a to b. Steps. So here are some important steps. The first, find critical numbers. The second is write intervals between those critical numbers. The third is substitute a value from each interval ratio into f prime closed interval x to test it. The fourth is indicate how the function behaves from the rules above. Okay, so here's the first example. The question: find the open intervals on which f(x) is equal to x cubed minus 3 over 2x squared is increasing or decreasing. Okay, so the first step is find critical numbers. Then we got critical numbers are x equal to 0 and x equal to 1. Then write interval and test value. Okay, so we just plug in those critical numbers in it. Then the third thing we do is just indicate how the function behaves. Then we just got so it's increasing in closed interval, well, negative infinity to 0, and in closed interval 1 to positive infinity. Yeah, and it's decreasing in closed interval 0 to 1. Okay, that's it. And here we're going to introduce the first derivative test. So let's see the critical numbers of a function if it's continuous on an open interval containing c. If f is differentiable on the interval except the possibility at c, then fc can be classified as follows. If f prime x changes from positive to negative at c, then f has a relative minimum at cfc. If f prime x changes from negative to positive at c, then f have a relative minimum at x equals c and y equal to fc. If f prime x is positive on both sides of c or negative on both sides of c, then fc is neither a relative maximum nor a relative minimum. Okay, so let's go to the next slide. Okay, so the first graph is a relative minimum. So we can see it start from decreasing to increasing. And the second graph is relative maximum. So we can see it start from increasing and end with decreasing. And for the third and fourth graph, they are not relative maximum nor relative minimum because it's keeping increasing or keeping decreasing. So there's not a maximum or minimum. Okay. So this is a example question. Find relative extrema and increasing c or decreasing c. In intervals of fx is equal to 1 over 2x minus sin x on the open interval at 0 to 2 pi. Okay, so the first step is find critical numbers. And just go through some basic calculations. Then we got x is equal to pi over 3 and 5 pi over 3. Then write in interval and test values. Yeah, so just plug in those critical numbers into the chart. Then we got it. Then we find out that it's increasing in the closed interval pi over 3 to 5 pi over 3, and it's decreasing in closed interval 0 to pi over 3 and closed interval 5 pi over 3 to 2 pi. Yeah, and we can find out the relative maximum is x equal to 5 pi over 3. Because in this situation, it start with it start with increasing and with decreasing, and the relative minimum is x equal to pi over 3, because it start with decreasing and with increasing and form a relative minimum. Okay, here is another example question. If the relative extrema and the increasing c or decreasing c intervals of fx is equal to x with power 4 plus 1 over x squared. Okay, so the first step is find critical numbers. Okay, just go through some basic calculation. Then we can get so x is equal to plus and minus 1. Okay, the second step is write interval and test values. So just plug in those critical numbers. Then we got this chart in the step 2. Then we can solve for the step 3, indicate how the function behaves. So we got increasing in closed interval -1 to 0 and closed interval 1 to positive infinity, and we got decreasing from negative infinity to -1 and closed interval 1 to and the closed interval 0 to 1. Okay, so we got the non-relative maximum, because function is dne at x equal to 0, but we got a relative minimum at x equal to positive and the -1, because in this situation, on the left of it, it was decreasing, and on the right is increasing. So we got a minimum. Okay, so the rest part of homeworks, let's welcome Nemo to explain to us.
So in this part, I'm responsible for making analyze for you to about the homeworks. So for the homework part, it's on page 183 and with the question of 9 to 14, about 6 questions of solving the functions, and 57 to 60, which are basically about the graphs and how it behaves. We have about 91 to 96. They're basically about the true or false questions. So let's get into it. So the first question is about g of x equals to x squared minus 2x minus 8. So what we're gonna do is we're gonna first take the derivative of it and find some of the solutions. As we just know, what we just used to do through Shichen's process was find the solutions and plug in the critical numbers in it. So we just follow the instructions, right? So we first take the derivative of it, like 2x minus 2, right? Then we take the solutions and zeros of it, right? Then we got the solution is x equals to 1. Then we plug it into the table and find some of the critical numbers, right? Then we find in this chart or this table, we can find the entire tendency of the entire graphs, so that we can infer about the answer of that. The increasing is from 1 to positive infinity, while the decreasing part was about negative infinity to 1. So the relatively minimum was on x equals to 1. For the second one is h of x equals to 12x minus x cubed. So in the same way, so we're going to take the derivative of it, right? So we taking the derivative of the function, we get 12 minus 3x squared. Then we take the solutions or zeros of it, right? Then we got 3x squared equals to 12. and we x squared equals to 4. So x equals to positive and negative 2. So we in the next step we plug it into the table and we got the sum of the critical numbers of it, and we get the tendency of the entire graph, right? So we got the function which is increasing from -2 to 2, and it decreases from the negative infinity to -2, and another range from 2 to positive infinity. So the relatively maxima is x equals to 2, and the relatively minima is x equals to -2. For the third problem, it's a relatively weird to know, since we do have the square root here already over here, right? So we're gonna transform about the platform or format of that. So we change the square root in the power of 1/2. So in this case, what we can infer about that is we can easily take the derivative of that, since it's hard for taking the derivative of the entire square root, right? So then we gotta simplify the entire graphs, entire function, since it's a very long term, like, right? It's a very long polynomial and exponential function. So we got we in this step we find the zeros of it, and finally we get x equals to positive and negative 2.828, right? So then we follow the instructions, we plug in into the critical numbers into the tables, right? So we find the entire tendency of the entire graph, right? So then we got the answer of that. So the function increases from negative 2.828 to 2.828, and it decreases from negative 4 prime negative 2.828 to 2.828 prime 4. Then it's the relatively maximum is x equals to 2.828, and the relatively minimum was x equals to negative 2.828. Sorry for the problem of that. So then we got into the fourth problem. So in this case, we can infer from the experience we solved the third problem. So we also need to transfer some of the parts of the function so that we can make it easy to take in the derivative. So in this case, since the function, the original one was y equals to x plus 9 over x, right? So in this case, we transform the entire 9 over x to 9x with the power of -1. Then we take and then we solve the entire function, and we got the the solutions of it. So we got x equals to positive and -3. And it also, as a reminder, we cannot ignore it doesn't exist at x equals to 0. So we plug the values into the table, and we got the entire tendency of the graph, right? Like I just showed there. So we got the answer of that. So it increases from the negative infinity to -3 to 3 prime positive infinity. Then the function also decreases from -3 prime 0 to 0 prime 3, right? And there's also the relatively maximum and relatively minimum from in x equals to x equals to -3, and relatively minimum we got x equals to 3. So in this case, we got the range for the limit of the x value, right? So this question is mainly based on the trigonometric function. So, but it's also easy to solve by following the instructions we told you in the previous PowerPoints. So what we're gonna do is firstly take the derivative of that. So we got the derivative of the f of x is equals to cosine x, right? Then we get the solutions and zeros of it. Then we got x equals to pi over 2 and 3 pi over 2, right? Then we plug into the chart. Then we got the answer of that. So the entire function increases from 0 prime pi over 2 to 3 pi over 2 prime 2 pi. And it decreases from pi over 2 prime 3 pi over 2. Then it also got the relatively maximum from at x equals to pi over 2, and it also got the relatively minimum at x equals to 3 pi over 2. So let's get to a relatively advanced and mixed example about that. So it also got the limit from the x value, right? So by following the instructions, so we got x, the original function over there. Then we got the derivative of the entire function over there, right? Then we take the solutions of the entire function. Then we got the x value, which is 0 and 2 pi, right? Then we plug it into the different into the different critical numbers, and we got the chart of the critical numbers, right? We got the tendency of then we got the answer. So as a reminder, this time, since the tendency is about only for decreasing, so the only tendency of the function is decreasing. So the function decreases from 0 to 2 pi. So that's it. And so let's get into the second section, which is about the sketch of the graph. Uh, so as the first question, as you observe the graph like this, so it's a horizontal line, right? So since the definition of the derivative is the slope of the line, right? So by calculating the slope of the entire graph, you can know that the graph of the derivative of the function should be also a function, should also be a horizontal line, right? So in this case, we can infer about the graph about that since uh, so it looks like this, right? It's easy to understand, right? So let's get into the next one. So it's a linear function, right? So uh it's basically with the y-intercept with -1 and x-intercept with 0.5, right? So uh in this case, since it's a linear algebra, the slope of the entire graph should also be a constant number, right? So it should also be a horizontal line. But the only difference is it has the exact y value for that. So since the slope, we can calculate it with the help of the x-intercept and the y-intercept. So so the slope is 2, right? So we can get the entire graph as y equals to 2, right? It's easy, right? So next question, it's a parabola function, right? So parabola function, as we know, it was only one variable and with the power of 2, right? So in this case, it decreases from the first tendency, right? And it goes up, right? So it goes down, right? And then goes up, right? So by analyzing this tendency, we can also infer the uh, the tendency of the entire derivative and the shape of the derivative of the function, right? So it basically looks like this. So since the slope of the entire graph was approaching to the negative from before the 2, which is the critical number for the entire graph, so it was on the negative range, right? But after getting the 2, right, we got positive and it goes up, right? So it's approaching to the positive y value for that, right? So it's easy to understand. The next one is partially hard to understand about that. So, but we can also with our way for analyzing the entire tendency. So what we're gonna do is we're gonna also analyzing the entire tendency, right? So it goes down first, then it goes up, then it goes down, then it goes up, right? By analyzing this, we can get that. So since two of the important critical numbers were -1 and +1, so So we can also infer about another important point about this is 0, right? It's the original, right? Oh, it's the origin, right? So since the original function also crosses the origin, so the derivative function should also cross the origin, right? By analyzing the graph, we can also, so since it's decreasing first, right? So it should be a negative uh, slope, right? So it's firstly so the y value of the derivative test is always negative. Then it goes up, right? So at this section, they goes up and the y value is always above to 0. In this case, it just slipped since it's symmetry graph, right? So let's get into the last section about that. So it's true or false question, right? So question 91, the sum of two increasing functions is increasing. That's true. There's no reason why it's wrong, right? So since two of the increasing functions and they got add up, so it's got this, right? So it's true. For the question 92, the products of two increasing functions is increasing. That's false. Since here's an example. So if f of x is equals to x, so it's like this, and g of x is negative 1 over x, then their product is negative 1 instead of 0. So it's decreasing. So it just proves that it's wrong, right? So for the question 93, every ninth degree polynomial has 9 n equal 1, 9 minus 1 critical numbers, right? That's false, since we can also infer from one particular example, right? So f of x equals to x cubed, right? Then its derivative is 3x plus 3x with the power of 2, right? But we can see that the derivative of the function is equals to 0 only at x equals to 0, right? So in this case, they are false. So about question 94, an nth degree polynomial has at most n minus 1 critical numbers. That is true. Guess why? So this is the principle that we studied in the 10th graders. So that's exactly what we studied, right? So it's correct. So about question 95, there is a relatively maximum or minimum at each of the critical numbers. False. So according to the process what we studied before, so f of x equals to x cubed, the same example, right? So it has no relatively maximum or minimum, but does have a critical point at x equals 0. About question 96, which is the last question. The relatively maximum of the function f are f of 1 equals to 4 and x of 3 is equals to 10. Therefore, f has at least one minimum for some x in the interval 1 to 3. So that is correct. That is correct. So since we do have the relatively maximum between 4 and 1 prime 4 and the 3 prime 10, this should be 1 to 3. There's a minimum point right over there. So that's it. So thank you for listening. Thank you for listening about our presentation or lesson about this first derivative test and some of the critical numbers like that. So thanks for listening.
Thanks for listening.
看了，结束录制。